All right, hi everyone. We're back. My name is Devin. I'm a senior researcher here at LEOMO in the Applied Sports Research Group. We're going to be looking at raw data again. This time we're going to be focusing on data from our gyroscope. In our last video we looked at IMUs in general and took a closer look at acceleration. So if you missed that, it might be helpful to click back to that video. Today, like I said, we're going to look a little bit more closely at gyroscope data. Gyro is a little bit easier to understand. There's kind of more colloquial terms we can talk about, and we will get started. So looking at the coordinate system, just like we did last time, we're going to define our IMU coordinate system for rotations. So the gyro measures rotations about the x, y, and z axes. So as you can see in the diagram here, the best way to think about this is if you're looking down the x-axis, in the positive x-axis, and you perform a rotation counterclockwise, you will have a positive gyroscope signal. And if you are looking down the positive x-axis and you perform a clockwise rotation, you will have a negative gyro signal. So clockwise and counterclockwise are kind of the colloquial way that we typically refer to rotations. And of course that works for all three axes. If you look down the positive y-axis and rotate it counterclockwise and clockwise, you'll have positive and negative gyroscope signals. Same thing with z. You can see with my rotation here, positive and negative gyroscope signals. It's pretty straightforward. Again, it's a little bit easier talking about gyro because we're already talking about a rate of rotation. It's the unit, of course, is degrees per second or radians per second. On the LVS app, they're reported as degrees per second. Thinking back about a zero cross event, what does a zero cross mean for gyro data? That's basically either you're not rotating at all, and that's a constant zero, or it is the point at which you stop rotating clockwise and begin rotating counterclockwise, or vice versa. And at that instant, you're not rotating. For example, we could do that demonstration here. You can rotate back and forth in Z, and at each point where the zero cross, at each zero cross, we are not rotating the sensor. So that's a little bit easier to comprehend as far as what zero means for raw data. We talked about positive and negative. So then I guess the only other thing to mention would be identifying certain motions. So when thinking about broad motions that may not occur about the center of the coordinate system of the IMU, if you're talking about broad motions, maybe it's a sweeping motion or something like this, you can easily identify clockwise and counterclockwise rotations of the object that you're rotating, my hand or my wrist, for example, by looking at the appropriate gyro signal for the IMU. So in this case, if it's a rotation primarily about the z-axis, we're not only rotating about the z-axis, we're also translating, but that amount of rotation in the local coordinate system of the IMU still shows up as a clockwise and counterclockwise rotation in the z-axis. And you can see that here in gyro z. We're having primarily a response from the gyro z-axis. Of course, if we were to do the same thing but about a different axis, for example x, you would see a larger response from gyro x. And likewise, if you were to do the same thing about the y-axis, you would have a gyro y response. As you experiment with IMUs and applying this to your own practice, hopefully you can refer back to these videos for a little bit of raw data analysis kind of review and how to really interpret the raw data that's coming from our IMUs. Thanks again, and we'll see you next time.